All right, we're going to start with our third example here. F of x is equal to 7 to the power of x. I'm going to put that in the calculator. I notice that my a value is 1, so this is also going to be another parent function. So I have 7 to the power of x. I'm going to go ahead and find my table on this, second graph, and I get my table of values. I'm going to see that it starts off for an input of -2 at some value of 0.02, that's small. For an input of -1, I get 0.14. An input of 0, I get 1 as I expected. And then 0.01. That's what all of our exponentials that are parent functions are going to go through. Parent function meaning that the a value is 1. Okay? And then for 1, an input of 1, I have 7, and an input of 2, I have 49. So this function is going to rapidly increase. I'm going to go ahead and graph it in 0, 1 here. I'm going to then graph my 1, 7 point by going to the right 1 and up 7. My second point, 2, 49, I go to the right 2 and way up 49. I'm just going to kind of guesstimate it up there. And I know that this function's increasing, so it's going to look something like that. And it's going to go way up. That's an increasing function. My -1 and -2 values, as x approaches then -infinity and gets smaller and smaller, y is going to go smaller and smaller, approaching that value on that asymptote. That's at y equals 0. It's going to get smaller and smaller and tend towards 0 as x becomes more and more negative. Looking at my numbers and looking at the graph, I see that as x increases, y also increases. I see that my base is 7, so my base is equal to 7. 7 is greater than 1, therefore I'm a growth function. Okay. My domain, again, is -infinity to +infinity. That's pretty standard for your exponential functions. And again, my range, if we're noticing this, our range here seems to be from that asymptote at y equals 0 all the way up to infinity. So these are all pretty consistent. Again, I can't go below y equals 0. I don't get to y equals 0, so again, that's why I have brackets or parentheses here. All right? Looking at we have 2 more examples here. F of x is equal to 0.75 to the power of x. Again, I'm going to put that into my calculator, y equals 0. Clear whatever's in there first. 0.75 to the power of x. I guess I could have put that 0.75 in parentheses. Probably should. So I'm going to redo that just to get in that habit of putting my base in parentheses. I should probably clear the whole thing first. Now that I've done that, very good, I go second graph, and I see again my values here. I start off for an input of -2. My value is 1.78. A value of -1 is 1.33. I go through that point 0.1. As usual, again, it's a parent function. My a value is 1. At 1, an input of 1, I get 0.75. And at an input of 2, I get 0.56. Now, looking at these, this is pretty intimidating, the graph, because I don't have whole numbers here. But nonetheless, I shouldn't panic. First of all, I'm going to go through 0, 1. So that's a good one to graph. I know that this is a decreasing function. My b value, 0.75, is between 0 and 1. Therefore, it's decay. I see that as x increases, y is decreasing. So again, this is going to be exponential decay. So I know it's going to start high and finish low. To graph the point -1, 1.3, I'm going to go to the right one, or to the left, sorry, I'm going to go to the left one. I'm going to go up 1. I'm not going to quite make it to 2, so it's just a little bit above 1 should be that point, 1.33. At x equals, at my point -2, 1.78, I'm going to go to the left 2 and up almost 2, but not quite. To graph 1 and 0.75, I'm going to go to the right 1 and up about 3/4 of the way to a 1. To graph 2.56, I'm going to go to the right 2 and about halfway up. This is going to be a very sloping function. Again, it's going to approach y equals 0 but not quite reach it. And as I become more and more negative x, my function will increase more and more rapidly. Okay? This is a good approximation. Again, as usual, I see this asymptote at y equals 0. My numbers will continue to get smaller. 0.75, as I continue to multiply a value by 0.75, they'll get smaller and smaller. And imagine slicing up a pie. As I slice up the pie, each time I slice up the pie, the slices get smaller and smaller, but the pie slices never actually get to 0. They just become smaller and smaller and smaller and smaller. And no matter how many times I slice up the pie, I never get to the point where a pie slice is equal to 0. That's kind of the concept here. After all, 0.75 is equal to 3/4. So as I keep on cutting something into 3/4 pieces, it will get smaller and smaller, but not quite ever reach 0. My domain here, just like all the other ones have been, is negative infinity to infinity. And my range, again, my minimum y value is 0. I don't quite reach 0, I approach it, therefore parentheses. And my maximum y value, well, as x becomes more and more negative, as x decreases, my y value continues to increase, and that'll reach towards infinity. One final example here, f of x is equal to 1 to the power of x. Now this one's different. And let's ask ourselves, we're going to look at the base here. My base is equal to 1. So what do I have, growth or decay? Well, in this case, I'm going to have neither. My base is equal to 1. Let's prove that. Y equals, enter our equation in, 1 to the power of x. Now, let's think about this logically. If I continue to multiply 1 by itself, what do I get? Well, I'm going to always end up with 1. So it doesn't matter what my input is, my output should always be 1. Let's go ahead and confirm that with our table, and sure enough, my output is always 1. I will, of course, go through 0, 1. We've talked about that point. For any parent function exponential, we're going to go through it, 0, 1. But here's the twist. Every other point will go through an output of 1. 1, 1, 2, 1. Negative 1, 1, negative 2, 1. And this becomes a straight line. And really, it's hard to say that this is an exponential function at this point. My domain here would be negative infinity to positive infinity. And my range, well, there's only one y value that I have. So my range could be written as y is equal to 1. As an aside, I could go back and rewrite each of, oops, that shouldn't have popped up. I'll take care of that. I can go back to and write each of my ranges also in another form. Since my range here is from 0 to infinity, I could rewrite this as y is greater than 0. It's not equal to 0, but y is greater than 0. I can do the same again on this function. Since my range is from 0 to infinity, I also could say y is greater than 0. That would be another way to write my range. Again, same thing for here. Y is greater than 0. And on this last example, and then this example again here, y is greater than 0. So as I think about it, it's also good that I can express my range in multiple ways. In range here on this equation, though, when our base is 1, it's a straight horizontal line, so our range is y is equal to 1. All right, and now all you have is your assignment. That assignment will be due on Tuesday. We'll probably quiz on this material and Monday's material on Tuesday. So be prepared for a quiz on Tuesday, and I will see you in class on Monday.